up on the way in, final balancing act. And what this sheet has is a long list of chemical equations. What happens in a chemical reaction is you start with reactants, things on the left side of the arrow. For example, that would be the zinc and the HCl. Then they create new products. The elements rearrange themselves. Now, the mechanism of how they rearrange themselves and why they form certain things is what we have to go over later in this unit. Today is not about you trying to figure out what they make. Today is about, hey, here's the entire reaction. Can we write it out properly? Because what you will notice when you look at this chemical equation is that the number of atoms on the left and the right side of the arrow have to balance out. That's conservation of mass. You can't create more stuff by making a reaction. You can't lose stuff by making a reaction. So in other words, I see a total of 1 zinc on the left side of the equation. I see 1 zinc on the right side of the equation. I mean, zinc is now bonded to something, but the number of zincs remain the same, which it has to. On the other hand, I see 1 hydrogen on the left side of the arrow. I see 2 on the right-hand side. That does not balance. It does not make sense that we can magically create more hydrogen in this reaction. Unfortunately, what some students would do then to make this balance is get rid of that 2. But that's not correct. You cannot change the formula of a compound just to balance an equation. Because hydrogen is diatomic. It is H2. You can't change that any more than when you look at ZnCl2, you can't change that formula. Why is it ZnCl2? Because zinc's a +2 charge and chlorine's a -1. Again, today we're going to give you the formulas early on. So you don't have to worry about writing the formulas, but eventually that's going to come up. And a very common mistake that students make is they change the formula of something in order to make the equation balance. And you cannot do that. You cannot change the identity of a compound just to make the numbers work. So what do? What we do is we can use coefficients, numbers that can go in front of compounds or elements, in order to show how many of these things do I need with how many of those. For example, I would put a big 2 in front of my HCl, because now I do have 2 hydrogens on the left-hand side to match up with my 2 hydrogens on the right-hand side. Not only that, but that 2 counts for anything in this equation. So I have 2 chlorines on the left-hand side of my equation. I have 2 chlorines on the right-hand side of my equation. This is actually balanced already. So if I just, now if I were to write this out, I wouldn't actually circle it. This would be a balanced equation. So we use coefficients in front of to show how many of these things we need. Typically what you do is you work left to right. So pick the first element on the left-hand side. So if I look at this question number 2, I have 4 phosphorus on the left-hand side. Then I'd look on the right-hand side. I have 4 phosphorus there. Okay, that's a balance. I look at the left-hand side. I have 2 oxygens on the reactant side. I have 10 on the product side. So what coefficient should I use in order to balance this equation? A 5. Some reactions will require multiple coefficients to be put in them in order to make things balance out. Heck, there's a possibility that some reactions will require 0 coefficients, and they'll just work all on their own. That's perfectly fine as well. However, it's not that there's a 0 in front of these things. Once you write down the formula, there's assumed to be at least one of those present. I'll do number 3 with you, but then I'd like to give you a chance just to try this out on your own for a little bit. So again, number 3, I have one silicone on the left-hand side. I have one on the right. That seems balanced to me. I have 2 oxygens on the left-hand side. I only have 1 oxygen on the right-hand side. That tells me I need a coefficient. Notice how me putting that 2 in front of the CO, that's carbon monoxide, by the way, affects not only the oxygen, but the carbon. I have to keep that in mind. Because now, carbon on the left-hand side, there's only 1. On the right-hand side, there's 1 from the first product, and there's 2 from the second product. So that means I have a total of 3 carbons on the product side. I need 3 on the reactant side. Again, a balanced chemical equation is going to have the same number of each element on the reactant and the product side. A chemical reaction is things now mixing around and forming new stuff. So again, when it says sodium reacts with oxygen, that's your, hey, here are the reactants. Because when you see the words to form, that should give you an indication of, hey, that's my arrow. And then sodium peroxide is the product. So, let's write out the formula for each thing. Sodium. Sodium's Na. Right? Metals stand alone. They're not one of our diatomic elements. Heck, if I wanted to give the phase notation for a lone element, I could. Recall that your periodic table, if the element is written in black, that is a solid at normal conditions. If it's red, it would be a gas. There's only a couple things that are blue for a liquid. So lone elements, that would be your option. So I could write a phase notation if I want to. We might save that for a little bit later, though. Let's take one step at a time here. Sodium reacts with, means plus, oxygen. Oxygen is one of our diatomics. I've just written my 2 reactants. To form, arrow, sodium peroxide. This is one of the more tricky and unusual polyatomic ions. Peroxide is on your polyatomic ion sheet. It's O2 with a -2 charge, which means the formula for sodium peroxide is Na2O2, which I know is unusual. However, step number 1 of writing a balanced equation is just write out the reactants, write out the product. You're given the names of them, you should be doing the corresponding formula. Now that you've done that, figure out if you need to balance anything. And we balance by putting numbers in front, coefficients. We do not change the formula. There's one atom that's not balanced on this. Is it the sodium or the oxygen? Sodium. There's my balanced equation. Emily.
So since you have 2's in front of all of them, you can't use anything, right?
I only have a 2 in front of the Na. In front of would mean here and here.
But if you did have 2's...
If I had 2's in front of them, then I could reduce, yes. But you can't say there's a 2 here, there's a 2 for O2, because then you'd be changing the formula of oxygen at that point. Let's look at the second one. If it's a compound that we would not expect you to know the formula for, we will give that to you. For example, methane is CH4. That's actually what comes out of our gas jets. Methane burns in oxygen to form carbon dioxide and water. And this is the chemical reaction that occurs every time you light a Bunsen burner. You change it. It undergoes a chemical change. So, methane, CH4, burns in oxygen. Means it's reacting with oxygen, and I know oxygen is a diatomic. And reading this sentence, look for key words to describe what is where. The words to form are telling me, here's my arrow. Emma, what's the formula for carbon dioxide? CO2. Haley, what's the formula for water? H2O. Always start by writing balanced formulas. Don't worry about balancing it until you have the starting block set. By the way, I would typically leave a little bit of space in front of each element in order for you to tuck a coefficient in there. If you try to write too small a space, you're going to have to end up erasing to make it fit better. This equation obviously is not balanced. Caden, what can we do? What's one thing we can do to help balance this?
Add a 2 to the H2O.
Yeah, you notice there's 4 hydrogens on the methane. I need 2 more here. That will throw off our oxygens, however, Kale. So what can we do to balance our oxygens? 2 in front of the O2 here. Yeah, now it's balanced.